chart, impedance chart. We have discussed about impedance chart or Smith chart. Now we will discuss about the admittance calculation using the Smith chart. Up to now we have discussed about impedance calculation using the Smith chart. In that we have seen the Smith chart has two parts, the upper part and lower part. The upper part is for the inductive part, lower part is for the capacitive part. Along the center line, that is the resistive part, and any point on that will have a combination of resistance and reactance. On the perimeter or on the outer circle, it will be either inductance or capacitance. If it is on the upper side, it will be inductance. On the lower side, it will be capacitance. Similarly, along the horizontal line, it will be only resistance. At any other point, it will be a combination of resistance and reactance. Reactance can become capacitive or inductive. That we have seen. Then on the left hand side, we saw the leftmost point on the resistance line is the short circuit. Rightmost point on the resistance line is the open circuit. That also we saw. So it is between resistance, can be between open circuit and short circuit. Any value, that also we saw. Now instead of resistance, if there is a situation, or most of the situations that we are going to discuss later are using admittance. So can we use admittance on the J chart or the Smith chart? So let us discuss about that. You know what is admittance? Admittance is 1 upon impedance. Therefore, Y is equal to 1 upon Z. That we can write 1 upon Z. Z we know is equal to Z0 into 1 plus gamma by 1 minus gamma. Therefore, 1 upon Z is equal to 1 upon Z0 into 1 minus gamma by 1 plus gamma. Now 1 minus gamma we can write as 1 plus of minus gamma. Denominator similarly 1 plus gamma we can write as 1 minus of minus gamma. Y0, as you know, Y0 is equal to 1 by Z0. So Y0 is characteristics admittance. If Z0 is characteristics impedance, Y0 is characteristics admittance, and Y0 is equal to 1 by Z0. So that way, let us represent YZ in this plot. Then we can find out, as in the case of Smith chart, we can find out normalized impedance, normalized admittance. Normalized admittance Y in will be Y by Y0. So that will be 1 plus of minus gamma divided by 1 minus of minus gamma. That we can write in the resistance case, in the impedance case, we wrote it as Rn plus Jxn. For the admittance, it is Gn plus Jbn. Gn is the normalized conductance and Bn is the normalized susceptance. So this Yn can be written like this. Now, if you look at the expression has 1 plus minus gamma Z and 1 minus gamma Z. Let us define 1 gamma dash as gamma, minus gamma. So if we define gamma dash as minus gamma, then Yn is equal to 1 plus gamma dash by 1 minus gamma dash. Similarly, if you remember, Zn is equal to 1 plus gamma by 1 minus gamma. Compare these two, Yn and Zn, they have the same form. Yn is 1 plus gamma dash by 1 minus gamma dash. Zn is equal to 1 plus gamma by 1 minus gamma. Which means the form of another chart, if I go for an admittance chart, instead of the impedance chart, the form will be same. Which means that implies that the same Smith chart can be used as an admittance calculator. Instead of a impedance calculator, we can also use it as an admittance calculator because the form of Yn and Zn are same. They are not, expressions are not same, but the form of expressions are same. Since form of expressions are same, and from the form of Zn we have got the Smith chart, so we can use the Smith chart to calculate the admittance. So admittance, it can be used as admittance calculator. So what are the changes that will be made in the admittance calculator? In the admittance calculator, same thing, this red line now will not be a resistance line, it will be a constant conductance line. So this, on this line, on the red line, we will have constant conductance. So this will give us the real admittance value or a constant conductance. So sorry, not constant conductance, only conductance. There will be no susceptance. This will represent a conductance line, pure conductance line, which is the real admittance. Then the center point will be gamma dash is equal to 0. There it was gamma is equal to 0. In this case, gamma dash is equal to 0. Now gamma dash is equal to minus gamma. Therefore, for the center point, gamma is equal to 0. That represents the matching point. Okay. The leftmost point will be gamma dash is equal to minus 1. Gamma dash is equal to minus 1 means gamma is equal to gamma dash is equal to minus gamma. So minus gamma is equal to minus 1 or gamma is equal to 1. Gamma is equal to 1 is the open circuit. So you get the open circuit on the left hand side. On the right hand side we will have gamma dash is equal to plus 1. Gamma dash is equal to plus 1 means gamma is equal to minus 1. Gamma is equal to minus 1 represents the short circuit. So right hand side will be short circuit. Now of the portion above the red line, that will be capacitive now because Bn will be greater than 0. The portion below the red line will be inductive now because Bn is less than 0. Why this becomes like this? When Bn is greater than 0, why it is capacitive? Simply Xn, if you remember, if it is capacitive, then Xn is equal to minus J by omega C. Now if I invert that, that will be minus omega C by J, which is omega C, minus will go out, it will be J omega C. So when we inverted that, capacitance inverted, capacitive reactance inverted gives us capacitive susceptance. Therefore, if Vn is greater than 0, then it will be capacitive. So upper part will be capacitive, lower part similarly will be inductive. Okay. So you can use a Smith chart or Z chart for admittance calculation. Then how to calculate the impedance or admittance using the Smith chart, Z chart. As we have discussed up to now, this Smith chart, it can be used for either impedance or admittance calculation as long as we maintain consistency. The complex plane is either the gamma plane or the gamma dash plane. Gamma plane for impedance calculation, gamma dash plane for the admittance calculation. And what we are considering on the Smith chart is normalized impedance or normalized admittance. So the coordinates will be normalized impedance coordinates or normalized admittance coordinates. So we have to be consistent with that. If we consider normalized impedance coordinates, and then we have to consider the complex gamma plane, and we have to calculate the impedance. If we consider normalized admittance coordinates, we have to consider the gamma dash plane, and we have to calculate the admittance. So these things we have to be consistent. Then we will come to the Y chart. Like Z chart, we can also have a Y chart. Y chart will be Yn is equal to, as we discussed, 1 plus gamma dash by 1 minus gamma dash. For gamma dash, we can write minus gamma. So that is equal to Gn plus Jbn. Compare this with the Smith chart equation. Zn is equal to Rn plus Jxn, which is equal to 1 plus gamma by 1 minus gamma. Therefore, Rn is mapped to Gn, Xn is mapped to Bn, gamma is mapped to minus gamma, which is a 180 degree rotation. Gamma is mapped to minus gamma is a 180 degree rotation. So, if you rotate the Smith chart by 180 degree, that gives us a Y chart. Okay. For example, Rn is equal to 1 circle, rotated by 180 degree, that becomes Gn is equal to 1 circle. xn is equal to 1 circle rotated by 180 degree. That becomes Pm is equal to 1 circle. Next. So you can see this. We have just rotated the Smith chart. This gives us the Y chart. So you can have a Y chart or you can have a Z chart. They are mirror image of each other. Y chart is the mirror image of the Smith chart. Smith chart is the mirror image of the Y chart. Then otherwise there is no difference, and we have discussed what will happen on these cases. So this is Y chart as in the previous case. I am not going to discuss it. Now I will show you 4 possibilities for Smith chart. One is Z chart or the Smith chart. This is mostly used. Most common use is Z chart. Then Z chart can be used for admittance, which is the second one. In the top right hand side is the Z chart using for admittance. Then Y chart, that can be used for admittance, that is figure number 3. Then Y chart that can be used for impedance, that is figure number 3. All 4 are possible. I will stick to the past 2 only. When we are discussing the applications, we will discuss the past 2 only. Then also in the market there is a chart which is called YZ chart. We can get it from the internet, which is the normalized impedance and admittance chart. So both the charts are there. Both are superimposed and they give you a chart, that is the YZ chart. Then we will come to the standing wave ratio on this Smith chart. As you know, what is standing wave ratio? It is equal to 1 plus gamma L by 1 minus gamma L. So 1 plus gamma L absolute by 1 minus gamma L absolute gives us the standing wave ratio. VSWR definition is this. Then we know what is Zin. Zin is equal to 1 plus gamma by 1 minus gamma. That we write as 1 plus gamma L exponential 2j beta z by 1 minus gamma L exponential 2 beta z. That we can write as 1 plus gamma L absolute into exponential j phi m exponential j2 beta z by 1 minus gamma L absolute into exponential j phi L into exponential 2j beta z. Now on the maximum value of that, this value Zn, maximum value will be 1 plus gamma L by 1 minus gamma. 1 plus gamma L maxima by 1 minus gamma L maximum. Sorry, 1 plus gamma L absolute by 1 minus gamma L absolute. That will be the maximum value of Zn. So if you look at the maximum value of Zn on the Smith chart, this will be on the right hand side. From the center, if you move to the right hand side, those are going to give us the maximum value. Towards the left hand side, those will give us the minimum value. So those will not hit the maximum value. So if we move towards the right hand side, that is going to, wherever you meet the straight line or the horizontal line, that point will give, not only give you the resistance, normalized resistance, that value also is the SWR value. So that gives us that Rn is equal to maximum of 1 plus gamma L by 1 minus gamma. So SWR is given by the value of Rn on the positive real axis of the Smith chart, which is for Rn from 0 to infinity. So sorry, Rn from 1 to infinity. Examples we will see in the next class. So we'll stop here for today. Examples we will see in the next class. Come prepared. I have given you the lecture notes have been supplied to you. So read the lecture notes. Understand. If there is a problem, let me know. And next class we'll do hands-on. So you come prepared with the Smith chart. Take 8 to 10 printouts.